Hey, what would you do if you got 5 times more feedback in an AI product? We're going to talk about exactly this with Vitor, Zapier Central, to tell us exactly how they did it and what they did. We went from getting around 10 feedback submissions a day to about 40. And that was just by this small change alone. We finally had that initial chunk of label data, and we had a much clearer picture of where our systems tend to fail most frequently. Everyone in the team feels really empowered to go look at the raw data and help with the triage queue. Everyone starts to understand the value of looking at raw data. Hi, everyone. Nice to meet the ones who don't know yet. And I want to talk to you today about how we collect and analyze user feedback to make Zapier Central better with the help of our friends over at BrainTrust. And before I start, I wanted to give just a little bit of background context on Zapier. For those of you that don't know, at Zapier, we do a lot of stuff with AI. Our vision is really to make AI do the work for you. So you can see a bunch of examples on this slide. We have many AI-powered features in production today, ranging from things like the AI Zap Builder, which is a natural language to workflows creator, Zapier Copilot, which is a chat interface inside of the editor, which lets you both edit a workflow, but also debug runtime and test time issues. Custom Actions, which is also a new project where you can give it a link to some API docs. Then we generate a new integration for Zapier for you if we don't support it yet. And then there's a bunch more stuff. There's a list at the bottom, but go check out zapier.com/AI if you're interested. We really do a ton of AI stuff. Starting to sound like Tim Cook in an Apple presentation saying AI all the time. But today I wanted to talk about Zapier Central, which is the product that I've been working on lately. And Zapier Central is a very new product. It's our take on what if we could try to disrupt Zapier, the platform from within using AI. And it's both a chat with your live data and an AI automation platform all in one. We connect to live data from third-party apps and that we keep them in sync for you. So it's kind of doing RAG over files, but those files can be data from your third-party apps like Notion, HubSpot, Google Sheets, a bunch of other things. And we also let you interact and send data over to all of the 7,000 plus apps that the Zapier platform supports today. And you can also use it as a GPT style one-off chat whenever you want of product, which is fine. Or you could also use it to set up recurring workflows using natural language and then automate some later work. Instead of having to go through like a workflow builder, you just describe in natural language what you want. You give the bot access to some of your apps, and then it would just kind of do its thing. So this is kind of like our way to get a wedge into people that are excited about automation, but they are too scared about complex builder type of products. So an example here could be you have an assistant with the instructions. Every time a sales meeting is about to start, extract the attendees from the calendar event, go do a Google search for each one of them and summarize what you find, and then add them to a Met with me Google Sheet, and then DM me a final summary in Slack so I'm prepared for the meeting. And then you can keep this running in the background. It's going to do its thing. But whenever you want to ask questions about the people you've met with, you can also go chat to the bot and you can say, hey, have I met with this person yet? Or how many people from Canada have I talked with? Or stuff like that. And so today I wanted to tell you a story of how we used our feedback collection pipeline and how we consume all that signal today to help guide our product decisions. So typically when you build AI products, you want to optimize for getting the MVP from your users as fast as possible so you can start collecting feedback. And then you want to use that feedback to learn fast and iterate, right? So a very common loop is you build a prototype with a strong foundational model, and then you do some byte-based or perhaps a static list of evals that you curated by hand, or you have some synthetic data, and then you ship that to some users. You start collecting real-world feedback, and then you use that feedback to build more evals and improve your system. And then you just kind of rinse and repeat, right? Then once the model comes out, all of those evals are also going to be paying dividends because now you can swap to the newer model and you run your evals to examine what got better, what got worse, and then you can make a decision based on that and other factors, like cost and latency. If swapping the models makes sense for your product. So this is where we were at the beginning of the story. We were kind of entering this iteration loop. We had a successful MVP launch. People were excited about the product and some of the things it promised to do. They liked this take on AI-assisted automation. But because we support such a wide breadth of use cases, it was really hard to assess what use cases are we low accuracy at. And from those ones, which ones should we be paying attention to, right? Which ones have high trash rate to justify prioritizing? And which one of these are like just one loud user complaining and we can kind of either reject or ignore these types of use cases for now. And we also knew that we needed to vastly increase our eval coverage to hundreds of tests per quote unquote capability of our system. And also wanted to get end-to-end coverage of popular use cases that we saw users were building for and we're kind of like sharing on social media and we're excited about. So the release of GPT-4o also kind of acted as a bit of a catalyst for everything I'm going to talk about here because it really highlighted the need for better understanding of the discrete capabilities our product needed to support. We had like limited evals, and those helped guide the decision to move from 4 turbo to 4.0 at the time. But we were really blindsided on some use cases where accuracy got lower. And one example of that is recovering from a tool call with invalid parameters, where the model would just kind of get stuck bouncing between the two attempts to solve the issue over and over again. And then you would just kind of go in a loop, trying the first attempt and back the second attempt and back the first attempt, and you wouldn't really realize that it was stuck. And that was very surprising for us because everyone else was saying that this got better for them with 4.0, but it got worse for us. So we had some work to do. So step one in our journey was really to just like, let's just collect more feedback. We need more signal, right? Because we had such a wide range of use cases to support. We really have like a very tight vertical use case or product. We really needed our users to tell us what they were trying to build and where things didn't go as expected. And Zapier has been design partners with BrainTrust since almost the very beginning of our AI adventures. And we've been using BrainTrust for pretty much all of our AI product offerings. And it's been invaluable for us to accelerate that product flywheel of collecting feedback, turning them into evals, and then iterating for improvement. And for Central, it wasn't any different. When we started using BrainTrust, that's to literally the beginning. Thanks for correcting. So the first thing that we did for Central was we started logging like literally every single production run to BrainTrust. And this helped us really drill down to specific tool call, completion calls, subsystems, latency, token usage, costs, everything. It was really valuable. And we also had our eval pipeline already set up with that curated data set that we had. And BrainTrust makes this really easy to get up and running too. So then besides that, one of the interesting things that we discovered early on, and something that Jason also mentioned previously in the workshop, is that you really have to put in the efforts to get users to provide feedback. I think people are becoming blind already to these default thumbs up and thumbs down buttons that we add to our AI UIs by default. It's a little bit like ad blindness, right? We all just kind of ignore any ads on a web page nowadays. I feel like it's going the same direction. And initially we had that feedback system set up, but we had these boring, tiny feedback buttons on the top right, and they were like this muted color. And even though we were getting a lot of usage in our product, the feedback submission rates were abysmally low. And even when we did get feedback, it was almost always negative because people only bothered to submit feedback when they were very angry or something went wrong, like runtime error or something. But positive feedback is just as important, right? Especially when you're building an LLM system, because you need to know what's working well in production. You want to capture those and make sure you prevent them regressing in the future. You also can use them as positive examples for few shotting, potentially even like fine tuning later on. So we really had to figure out a way to encourage more proactive feedback, both positive and negatives. So now what we do is we're a bit more aggressive about asking for feedback, and we try to be more proactive about doing it in the right context too. So you can see a good example of this on the screenshot. At Central, when you're building a workflow, you need to test it at least once before turning it on, because that's going to pull in some sample data and kind of guide you through the steps one by one. It will stop along the way asking you if you want to provide any feedback so we can self-correct or if you want to keep going. So now when a test run finishes, we can add a normal looking chat message at the bottom and ask, did this run do what you expected it to do? And we can put bigger thumbs up and thumbs down icons right next to it. And when the user clicks on either of those buttons, we also did some work to provide some examples of what good feedback looks like, what good or negative feedback looks like inside of a preformed text field. And then the user can provide us some details on why this was good or bad. So this small change had a pretty huge impact by itself. We went from getting around 10 feedback submissions a day to about 40. And that was just by this small change alone. And we also started getting a lot more positive feedback too, which was the more surprising part of it. And the graph at the bottom, at the dark blue, are the positive feedback submissions. And we were totally not expecting that to be the case. And it was great because we really needed that feedback. It was surprising to us how Tinsel Miner could really increase the amount of feedback, basically 4x our signal. So we were really happy about it. And this was the first thing that we tried too. It really popped us up to keep doing more things. As an aside, another really key point I think it's worth mentioning is that the wording of the feedback request also matters. And initially we were going to ask something generic, like on that left side, like how do we do? But after talking to Jason, he suggested we go with something a bit more specific, which led to much better quality feedback, especially on the negative signals. Because for this pipeline, for this context specifically, we were more interested in whether the workflow was doing the right thing. It's a complex multi-step agentic blah, blah pipeline. I hate the word agentic, but that's topic for another day. So we worded our feedback request to nudge those kinds of feedback. We still cared about other things like, is the system slow, of course, but we monitored those in different ways. Another really useful strategy to complement explicitly asking for user feedback in the right context, being more obnoxious about it, is to mine user interaction in your app for implicit feedback. And there's actually a lot of low-hanging fruit possibilities here. And I think the difficult part is not coming up with ideas, but really just like wiring everything up in your app to track back and like correlate those events. So one easy option that I usually recommend people is consider running like a nightly job, really, that just fetches a bunch of runs from your database and then just runs a script locally to mine them for implicit feedback. It really doesn't have to be anything fancy. So using that same example I mentioned in the previous slide, after a user tests the workflow, if they turn the workflow on, that's a pretty positive signal that it's doing what they want, right? So we can treat this as an implicit positive feedback. On the other hand, if a tool call returned a validation error, then there's a high likelihood that our LLM made a mistake, and then we can treat this as an implicit negative feedback. Another good source of implicit feedback is just looking at the follow-up messages a user sends after the LLM responded. Here, the user is clearly letting us know that this can be treated as negative feedback. They were not very happy with the response. The problem with these ones is like sometimes they tell you that the response for the RAG system was wrong, but they don't really give you any additional context on why. So you're like scrambling a little bit to figure out exactly what was wrong, especially since we don't have access to any of the raw data from the data sources that our users add. We don't have like a static list of files or anything that's part of a RAG system. So this makes it really hard, but it's still really valuable implicit feedback, and it helps us fix a couple of issues in our pipeline already. And sometimes the user will send a follow-up message that is also mostly rehashing what it asked the previous time to see if the LLM interprets that phrasing better. And you usually see this with like more tech-savvy users, I think, where they just see an example on screen. They just kind of reword to try to put the subject first or change the words around and see if like to tickle the LLM the right way or whatever. I actually see a lot of this. So this is an interesting one. So you can get all sorts of fancy here too into like semantic comparison between them and stuff like that. It's a really fun topic too. Selfishly, it's a fun topic to work on if you have the time. Of course, hallucinations are another really good source of implicit feedback. And even though it sounds kind of hard to come up with the heuristics for detecting these, I think here's another benefit of spending time every day looking at your data, right? Like you start kind of building these intuitions about pathological hallucination cases that are common in your app. And in our case, the one in the screenshot was common enough that we could look for that specific phrase. You can replace and then something in square brackets to mine for that implicit negative feedback. And that helped us kind of get a sense of how often this was happening and if we should worry about it now or not. All right, so now we kind of had all this data and this helped decrease our signal by a lot. So the next step was really to try to understand that data more deeply. And our goal was to identify where we were failing most often and categorize those failures into buckets, and afterwards cross-reference this with the usage data to guide product decisions. So we wanted to focus on high traffic areas with low accuracy, right? Something we talked about in the workshop as well. If something was failing often, but had low traffic, then we didn't want to spend too much time on that right now. And we also wanted to take a lot of these examples and turn them into this way we could reproduce them locally, and then we could work on improving them over time, kind of go through that iteration loop, and also make sure that the examples didn't regress in the future either. It's really working with LLMs is kind of like a whack-a-mole sometimes. So we really want those positive examples in your system. And as for non-goals, we weren't really interested in an LLM as a judge pipeline, at least not yet, partly because we wanted to make sure we had enough human labeled examples first, and partly because I really wanted to encourage the team to help with labeling and to kind of get everyone in the groove of the like look at your data mentality, which is something I was finding that the team was liking at the time. So to help us understand the data, the first thing we did was we started adding a bunch more metadata. So every run gets post-processed for additional metadata, like a list of the tools that were used, the number of tools, the context on which that run happened, whether it was initiated by our Chrome extension, from a web app or Slack integration, and a bunch of other things. And this allows labelers to focus on a subset of feedback if they want to. For instance, we have one team internally that's focused on building the system that rags live data. So that team could filter by runs that had tool calls to their system and then do labeling only for those. It also allowed us to test some data hypotheses in the future, right? So the number of tools called in a run have any correlation to the success. Spoiler alert, it does. That's a pretty easy one. There were some more involved data hypotheses that we can test now. And here, Brain Trust also made our lives easier because it allows you to filter very easily all of your logs by any of your metadata properties. So we're just adding a bunch of stuff in there, and we can slice and dice some logs by anything that we were interested at the time.
Hey, are your RAG applications falling short despite using the latest frameworks and models?
You're not alone. I'm Jason Liu, and I've helped a dozen companies improve their AI applications. I've developed a systematic approach that delivers results. If you want to check it out, join my free 6-week email course and learn the techniques I use in my own consulting practice. That way, you can stop guessing at what works and measure what matters. Just check out improvingrag.com.
And then the next thing we did was we also built this internal feedback triaging system. where all feedback submissions will land on by default. And from here, you have an optimized view for staff to review everything about the run, label it, includes a representation of the chat history at the time, plus all the information that you might need to debug and understand the results. This is a paying user. What were the instructions for this run? Basically a big dump of data. And we were started up to the UI to what like information architecture, what do we need to present for a person that's trying to review this and understand what went wrong and what went right and label this into one of the categories that we care about. And it also includes a link to the trace and brain trust. And that's where we would go and we needed to dig into the details of each LLM call, the latency, the costs, all of the sub-steps. There's a bunch of sub-LLM systems involved in some of these. This really helped us do some more fine-grained debugging when we needed to. And from the triage page, a staff member can label the feedback with a category, and that maps back to one of the product capabilities that we're interested in tracking. And they can also add some notes with the findings, right? So they can help us later when we're creating an eval and the eval assertions for this run, so you can figure out. And sometimes it was very involved to try to understand what exactly went wrong with some of these. I think the most time was spent on trying to understand what went wrong because the user didn't provide enough context. So we had to really go dig into everything about their setup, then actually figuring out what went wrong with the actual LLM calls. So it was really valuable to add these triaging notes, like for the next person looking at these. And we also make it really easy to create an eval straight from the UI. In this case, this was a pretty complex pipeline. So we needed to do a bunch of mocking to simulate the production run. This involves a bunch of third-party calls to users, third-party systems. So we definitely don't want those to flow through, and they were not even going to work anyway. So we want to make sure that we mimic exactly the same run that happened in production, but we needed to mock some of those third-party requests. And we also use an assertion-based scorer. So we store this eval data set locally. It's a pretty involved like JSON representation for each eval row. But for other pipelines of subsystems that we have, we usually just have a button that adds a new row to a brain trust data set, or we just do it directly from the brain trust UI, which is also really easy. And now after getting to a data set, the eval will like load up that data set every time it would start. So all of these would get picked up automatically the next time we run the eval. So this is really handy for like small parts of your subsystem that you're trying to split out. So here, for instance, we have this planner subsystem that would help us build plan for doing some data analysis using Python code. And we had a data set specifically for this that we started adding. And it was really easy to just kind of go through the production logs and spot runs that we wanted to add to that data set. All right. So at this point, the triaging system was set up. We were getting a lot of data. At some point, we had about 500 feedback submissions needing triaging. And I was still doing these mostly by myself or trying to do these mostly by myself. So I really needed to find a way to scale it up. And that's why we came up with this idea of doing labeling parties. It's just a fun way to say that the entire team would meet and we would look at the triage queue and label some feedback submissions together. And obviously this was slower than me just ripping through it and labeling by myself at the beginning, of course, but it really helped build our team members' confidence that they can help with labeling on a daily basis. And after a few weeks, everyone was feeling more confident to triage also daily a few submissions by themselves. So it's really helped the system kind of scale up. This also helped encourage the look at your data mentality. I felt like I had to have look at your data in at least one slide to kind of keep with the motif of the workshops. And this was actually really true because every week we would find valuable insights in looking at the queues. And they really started understanding the value of staring at the raw data. And I think this was, for me, perhaps an even better outcome than anything else from this whole effort. It's like everyone in the team understands that you need to look at the raw data. And not only that, they're also not afraid to go look at raw data because they know how to interpret it correctly. They know how all the pieces of the system fall into place. We also often end up finding like very interesting examples, just spurred tangential like prioritization discussions. So in general, these calls were like really high ROI, even if we spent like an entire hour just talking about the same feedback to be labeled, because we will always come out of it really happy that we took that time together. So then we were collecting all of that extra data and we had some mechanisms in place to understand it. So it was really time to put it all together. Now is where we can really start profiting and start seeing like the flywheel starting to turn a little bit with some human involvement for now, but it's better than nothing. We finally had that initial chunk of labeled data and we had a much clearer picture of where our systems tend to fail most frequently. And for instance, we have a tool called AI Actions, which takes a natural language description of how to invoke an action in a third-party app. And then we translate that natural language description into the parameters that you have to pass to the third-party API. Some third-party APIs are really confusing. I'm looking at you, Google API. Sometimes we would guess the parameters wrong, or even worse, you would make up parameters that were missing from the description instead of asking for clarification, right? So classic example that we had in the beginning was if you say something like send a DM in Slack, at the beginning, what AI actions would do, you would just send a DM to a random person in your Slack workspace instead of getting back to you and saying, okay, I can do that, but who do you want to send this DM to? And so now we knew that this was the most critical issue that we needed to pay attention to right now. And besides all this data, we also gathered, which apps for this subsystem were failing more often. So we knew that Google Sheets was the largest offender when it came to this category. So we've since put a lot of effort into improving the accuracy of Google Sheets action, like add a rule to this Google Sheet, update it, and kind of stuff. So we also started feeding all of this data into our analytics platform, Databricks. We're able to cross-reference all of this with our product usage, which is pretty awesome because now we can use this to inform some of our process, right? For instance, when we released our Chrome extension, we started noticing that people were using the Chrome extension really heavily. But even though we had this feature in the Chrome extension where you can ask questions about the current Chrome tab, very often the LLM would go call fetch as a browser tool and fetch the URL that you were in instead of just using the context of the current tab that we were already providing the LLM. We identified this and we knew that this was an important issue for us to fix. So in total, as of today, we went from 23 curated evals that we had in the beginning that started off as a Google Sheet and then ended up in BrainTrust to what we have now, which are 383 evals and growing. I actually had to update this slide half an hour ago because they had already changed. But so now we're way more happy. This is going to keep growing. And most of these are also based on live runs. So this is really great because it allows us to, run these whenever we want and feel way more confident that any change that we're making to our system is not going to cause any big problems to our users. And some other outcomes today, as I said, I think this is one of the parts that I was most happy about. Like everyone in the team feels really empowered to go look at the raw data and help with the triage queue. Everyone starts to understand the value of looking at raw data. And more importantly, I think the discussions that we have as a team, they're more focused on improving specific capabilities now. Previously, there was a lot of hand waving and kind of generic, we need to make things better discourse. And now things are more targeted. So that's really exciting for us. As I mentioned earlier, one of the catalysts for this whole effort was the release of the GPT-4o model. And we feel much better equipped to make a decision on switching models when we need it now. And a recent example is how the latest snapshot of GPT-4o regressed some of our evals. So instead of swapping right away, even though it was a cheaper snapshot, we had to wait and we decided to spend a few days doing some prompt tuning before we roll it out. And of course, the flywheel is starting to spin. We can see activation and retention in the product starting to trend upwards. The ratio of positive to negative feedback submissions is looking good. And even though we need some of that human help for the labeling now, I think one of the next steps we're already thinking of is how can we up this a little bit more? Right? And I'm very excited to apply some of the ideas that I learned in the workshop too, where you try to build some sort of LLM as a judge, at least to kind of draft the initial suggestion of the labeling for some of those feedbacks, and then have a human just read through them yes, okay, not okay. And then we go from there. Cool. That's everything I had. Thanks for listening.
Thanks for watching. If you liked that video, make sure to like and subscribe. And if you want to learn more, check out improvingrag.com. We're going to talk about the foundations and not frameworks. Over 6 emails, you're going to learn how to overcome absence blindness, as well as how to fine-tune language models, understanding diverse query types, improving multimodal RAG, and ultimately smart question routing, and build a UX that collects user feedback. Just check out improvingrag.com and fill out this quick email address at the bottom.